Morning, sir. I am Sirisha from Tribly department. Today, my topic is separation of losses test. Total losses in DC machine three types: copper losses, iron losses, mechanical losses. Copper losses divided into three types: armature copper losses, shunt copper losses, series copper losses. Iron losses again divided into two: hysteresis and eddy current losses. Mechanical losses again divided into two: frictional and windage losses. First, we discuss about iron and magnetic losses. 20 to 30% of full load losses. Hysteresis and eddy current losses. Hysteresis losses. The losses is due to the reversal of magnetization of the armature core. Every portion of the rating core passes under North Pole to South Pole, alternating. They are at a time south and north polarities respectively. The core undergoes one complete cycle of magnetic reversal after passing under one pair of pole. P is equals to number of poles. N is equals to armature speed in RPM. Frequency of magnetic reversal. F is equals to NP by 120. The losses depend upon the volume and V max and frequency of the reversal. Hysteresis losses is given by the formula Wn is equals to NB 1.6 B max FV watts. V is equals to volume of the core in meter cube. Eddy current losses. When the armature core rotates, it cuts the magnetic flux. Hence, a EMF induced in the body of the core according to the Faraday's laws of electromagnetic induction. The EMF thoughts small set of the large current in the body of the core due to the resistance. The current is known as eddy current. There, these are core lamination are insulated from each other by a thin coating of varnish. Due to the core body being one continuous solid, iron losses. The magnitude of eddy current losses is large, as armature core selection area in the large itself. Resistance in small, hence eddy current losses in large. Their small core has been split up in thin core selection has every high resistance. Hence, magnetic of the eddy current losses is reduced. Considerably, they are reduced by the eddy current losses. We is equals to KB square K KB square max F square T square V square watts. B max maximum flux density. T is equals to frequency of the magnetic reversal. V is equals to volume of the armature core. T is equals to thickness of the lamination. W is equals to T square. Hence, T should be kept in a small as possible as. Eddy current losses Eddy current losses is reduced by laminated core, but hysteresis losses cannot reduced by this way. Hence, hysteresis losses and eddy current losses are the component of the iron losses. For applied flux density B max to the core, we have hysteresis losses AF and eddy current losses BF square. They, then the on-load losses can expressed as WC is equals to AF plus BF square 1.36, where A and B are constant. Therefore, WC by F is equals to A plus BF, as shown in figure graph, which is a straight line when WC by F and the plotted plotted along the axis y-axis and x-axis respectively. The intercepts of the y-axis given the value of the value, whereas the slope of the line gives the value of b. Now, hysteresis and eddy current losses can determine the desired frequency. The experimental circuits arranged for the determining WC by F and F is shown in figure. Variable frequency alternator supplies to the transformer under test, which is driven by the DC shunt motor whose speed can be varied over a wind range. The switch the switches S1 and S2 are open and the alternators is started. With the help of DC shunt motor, the speed is adjusted to this graph. This is graph and this is the flow diagram of the separation of losses test. Exponential circuits of determining WC by F and F value of the required frequency. The excitation of the field coils is varied until the voltmeter on the secondary side of the transformer achieves the rated value if E2 is the transformer EMF on the secondary. We have E2 is equals to 4.44 pi m f pi m free Fn. That is E2 by F is equals to 4.44 pi m n. The constant E2 by F, the flux intensity in the transformer remains constant. To achieve this, frequency of the alternator EMF is varied so that E2 by F remains constant. The necessary F can be adjusted to the vary E2 so that E2 by F is kept in constant for different values for frequencies. Above and below the rated values readings, wattmeter is noted. The graph WC by F and F is drawn to the get constant A and B. After getting the value A and B, the hysteresis and eddy current losses is obtained. Advantages of separation of losses test. Improve transformer designs. Help engineers design the transformer with optimized material and structure to reduce the losses. Changes operational efficiency. Enable users to operate transformer close to optimal load levels. Reduce operational cost. Lower energy losses leads to reduce energy consumption and cost saving. Thank you, sir.